So tonight we are going to work on verifying our trigonometric identities. We're going to use the same process that we did with all of our algebra and trig identities, with substituting in, simplifying, canceling things out, all of that. Except this time, our trig is going to be so easy, we are giving you the answers. So the difference between just simplifying a trig expression and verifying a trig identity is that you know what you are working toward. You know that your final answer should be secant, or it should be 1. There's no question about when do I know when I'm done. You'll know you're done when both sides of your equation match. So here are the rules. You have to choose one side. Usually we're going to say that's the left side. That's not an all the time thing, but the left side tends to be a good one to start with, to work on, and you are not allowed to touch the other side. The other side stays exactly as it is. You are not using identities on the other side. Some strategies to help you verify that things are true. First of all, have fun. These are like little puzzles, and it's a matter of trying to figure out how can I get all of my identities to substitute in so that the left side is exactly equal to the right side. You'll notice that most of this list is what we talked about with simplifying trig expressions. Some things to point out, we also have included factoring. That might be helpful. And multiplying your top and a bottom by a conjugate. Remember a conjugate, if I have x plus y, my conjugate that I would multiply by is x minus y. In multiplying by a conjugate, you are forcing a difference of squares to happen so that you get either x or y to drop out. Okay? If all else fails, change to sine and cosine. Good strategy overall, in addition to having fun, of course, is to look at your final expression. Like I said, we're going to give you the answer. You're going to know what you're working toward, so do what you can to substitute in order to find that answer. Alright, so verify secant y times cosine of y is equal to 1. So I'm going to say leave this 1 alone. We're going to work with the left side. So secant of y is 1 over cosine times cosine. Okay, just carry this equals 1 down with you. Cosine and cosine cancel. 1 is equal to 1. Final answer. On a test or a quiz, you need to write left side equals right side, and it needs to be in exact matching form. If you want to, put a little check mark by it to show that you're done. You can also put this little proof box. That means I have completed and I have shown what I need to show. Alright, verify that the sine of b over the tangent of b equals cos b. Okay, more jokes. I'm just trying to make your life more fun. Cosine of b is what we're trying to prove. I'm going to say we're going to leave cosine of b alone, and I'm going to work on the left side. So sine of b is just sine of b. Not much we can really do with that. I'm going to turn tangent into sine of b over cosine of b, and I'm leaving that right side alone, just carrying it down with me. So now on the left side, I'm dividing by a fraction, so I can multiply by the reciprocal. Hopefully you can already see that your signs are going to cancel, and you're going to be left with cosine of beta equals cosine of beta. Final answer, done, proved. The left side is exactly equal to the right side. So again, nothing has changed. All the things we're doing on the left are just like what we practiced the other night, but now I'm just telling you what you need to simplify to before you get started. Alright, again, I'm going to choose to work on the left side, so I'm going to leave this one all alone. I'm going to start by, I've got cosines and sines already in here, so I think a good idea would be to probably turn tangent into sine and cosine. So cosine of x plus sine of x times sine of x over cosine of x. Just to save some writing, I'm just going to put the equal sign. We know that the secant squared is being, or the secant of x is being carried down the whole time. Alright, so now I'm at cosine of x plus sine squared over cosine. Alright, well, that hasn't really gotten me very far. not very simple. So the next thing I want to look at is I want to consider finding a common denominator, so I can add these two terms together. Cosine of x is the same thing as cosine over 1. So to find my common denominator, I'm going to multiply by cosine of x over cosine of x, because I want my denominator to be cosine. So on the left side, I'm going to get cosine squared of x over cosine plus sine squared of x over cosine. Because these have a common denominator, I could say cosine squared plus sine squared all over cosine. Using your identity sheet, I'm sorry I forgot to remind you to take it out, but you should have it with you. Cosine squared plus sine squared is a Pythagorean identity equal to 1. And 1 over cosine is equal to the secant of x, which is equal to our right-hand side that we were trying to prove. So you're done, because that secant carries all the way down. Alright, this one looks messy. It looks really messy. But it helps to start with the messy side and try to simplify it to be equal to this over here. So to start, I'm going to do some algebra and I'm going to distribute these things in. So this will end up with secant to the 7th of x times tangent. Remember, secant doesn't have to distribute to the tangent because we've got multiplication happening. This one to this term will end up with secant to the 5th of x times tangent of x. Alright? Using what I'm trying to simplify to over here, I want to simplify with something with secant to the 5th. So I'm going to say a good strategy. I've got too many secants right here. I'm going to try to factor out whatever these things have in common. Well, this one has 7 secants and a tangent. This one has 5 secants and a tangent. So at most, I could take out 5 secants and a tangent. I'd be left here with 2 secants left over. And I'd be left here, well, this is exactly what I took out. So with a minus 1. Now, secant squared minus 1 is one of our Pythagorean identities. So I've got secant to the 5th times tangent of x, all times tangent squared. Tangent times tangent squared gives me tangent to the 3rd, which is what I was working toward. I'm done. So again, that one, I used the fact that I was trying to get to a secant to the 5th to know that I should probably factor out something here because secant to the 7th was too high. If you've forgotten that method of factoring, really what this said was y to the 7th times x minus y to the 5th times x, and I factored out a y to the 5th times x, I'd be left with y squared minus 1. Okay, this one, secant of beta minus 1 all over 1 minus cosine of beta. So a good strategy here might be to try to multiply by a conjugate, but what ends up happening if you multiply by a conjugate on the bottom, things don't actually get simpler. They get messier, and they get messier really fast. If you don't trust me, try on your own multiplying by 1 plus cosine and 1 plus cosine. I promise it's not going to be pretty, but you can try it if you don't trust me. My suggestion here would be to think of secant as 1 over cosine minus 1 and 1 minus cosine of b. Now, to clear this double fraction that I have going on, I'm going to multiply this top by cosine But if I do that to the top, I also have to do that to the bottom. Distributing in, cosine of beta times 1 over cosine of beta, those will cancel. Cosine will distribute here, so this will become a minus cosine. On the bottom, I'm going to leave this just as cosine of beta and 1 minus cosine of beta. This term and this term are exactly the same. Cancel them. 1 over cosine, which is the same thing as secant, which hopefully that's what I was proving. I think it was from the beginning. Those two things are equal. Okay, so again, if you want to multiply by a conjugate because you think that that'll help create that difference of squares, you can, but it's going to get really messy, and I would advise against it. Alright, secant minus cosine, trying to turn that into sine times tangent. I'm starting with subtraction, and I'm ending with multiplication. So a good method here is going to be to try to combine these two things together using common denominators. Well, first, let's figure out what our denominator would need to be. Okay, so our denominator we're going to want is cosine. So I'm going to multiply this one by cosine over cosine. So this will leave me with 1 over cosine of x minus cosine squared over cosine of x. Now that these things have a common denominator, I can add them together. Well, in this case, I guess subtract them together. Using our Pythagorean identities, 1 minus cosine squared is equal to sine squared. And now it looks like I'm kind of stuck. But sine squared is sine times sine, and I still have a cosine in the bottom. This cosine only gets written once because this is multiplication. We're not separating our fraction over addition or subtraction. This right here, sine and cosine, are going to simplify to tangent. Sine of x times tangent of x is definitely equal to the sine of x times tangent of x. So again, the reason I need to do that is I was starting with subtraction and I needed to somehow turn it into multiplication. So a good method is to try to find a common denominator and add things together to be one term. Due to some time constraints on our video, we're going to use a little bit of movie magic, and I'm going to just fill in all of this for you. I'm going to do it one way in one color and the other way in another color, and then talk through it. Alright, option 1 is in green, and that's to work with the left side and get it to all simplify to this over here. Option 2 would be work with the red side, get it to all simplify to what is over here. So in this one, I factored out and I made it cosine squared and cosine. Replaced cosine squared with 1 minus sine squared. Then distributed this sine of x to 1 and sine of x to sine squared. So we get those right here times cosine. On this side, I kind of worked backwards. I factored out a sine squared, was left with 1 minus sine squared. Well, then 1 minus sine squared became cosine squared. Sine squared, cosine squared, and cosine gets you to this. But our sides have to match exactly, so I flip-flopped around the cosine to the third and the sine squared. Alright, that's the first one of trig identities and verifying. We are going to do another lesson on this because you just need to do them. You need to practice them over and over and over. Keep your identity sheet close to you. It will become your friend. You will want to use it. The sooner you memorize them or you just have a better understanding, the easier these will be. Also, practice. Practice, 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 practice. Alright, talk to you later.